Okay, good. Just trying to see if Bob, do you recall like a type of question that was causing trouble or
Sure. Let
um,
me dig through. Sorry, I just grabbed my scratch paper here.
yeah.
Let me dig through.
By the way, I do have another meeting at 10, so I do have to wrap up by 10, but I think that should be enough time for us to go through most of this.
I think so. Let's see. Um, yeah, that'll work. Let's go to, if you don't mind, question 3. I think 1 and 2. I'll take a look at them again, but I think 1 and 2 I'll be okay with
Okay.
because they kind of look like the standard I plug and play on the equation, and then we go from there.
Okay. So let me give you just a little bit of background. I think you're aware of this, but just to kind of do a quick recap. This normal distribution that's being discussed here is really based
Mm-hmm.
on this bell-shaped curve.
Right.
And we can measure many, many quantities that follow this kind of distribution. IQ scores, heights, weights, salaries, all of these follow this kind of a trend or this kind of a distribution. And so when you have a normal distribution like this, there's two important numbers, the mean and the standard deviation. The mean, let's say this is salaries, just to use an example. So I'm going to mark this horizontal axis as salaries. Sometimes we call this an X value. An X value is just whatever you're measuring. Could be salaries, could be blood pressures. And you put the mean right here in the center corresponding to the peak of the curve. So I'm going to
Okay.
use an example. I'm going to say the mean salary at my company is $50,000, let's say, just to make something up. So I would mark $50,000 here in the center. And then the standard deviation is a measure of how spread out the salaries are at the company. If many employees are making close to $50,000, that means all the data values are clustered together. The standard deviation will be small. But maybe there's a big spread in salaries. Then the standard deviation is a larger number. So standard deviation measures how spread out the salaries would be. Now, when you look at a curve like this, there's a certain point that's called an inflection point. And that inflection point might be like about here and here. What it means is where the graph is curving down. If you notice, this part of the graph is kind of curving downwards, kind of like an upside down bowl.
Mm-hmm.
But then at a certain point, the curvature changes and now it's curving up. Well, that transition point, these red dots, are called inflection points. So it's where the curvature changes from curving down to curving up. Why do we care about that? Well, this distance, if I drop this red dot down to the horizontal axis, let's say this ends up being here at $60,000.
Mm-hmm.
This distance from the mean to this inflection point is the standard deviation. So in my example, the standard deviation would be about $10,000.
Okay.
All right. Now, there's one other fact that's useful to know. And by the way, the mean has this symbol. It's the Greek letter mu. Looks like a U. And the standard deviation goes by this symbol. It's the Greek letter called sigma. You could see it here in this problem statement. They use the symbol mu, mu, and they use the symbol sigma to indicate mean and standard deviation. All right, well, this problem is saying what is the first quartile and what is the third quartile? Now, one other aspect of this normal curve is going to be finding areas under the curve. Let me give you my salary example again. So here is $50,000. If I want to know the percentage of people making more than $70,000, I'm going to mark 70,000 right here. I want to know what percentage of employees at the company make more than 70,000. Well, to find that answer, you find this area under the curve. So I'm going to mark to the right of 70,000 because I want to know what percentage are earning more than 70,000. That means go to the right. And I'm going to find this green area here under the curve. Let's say, just to make something up, that green area is 0.20. That's the area. My conclusion is then 20% of employees are earning more than $70,000. So when you want to figure out percentages, sometimes we call it percentiles, you are going to be finding this area under the curve, under this normal curve. It turns out the total area under the entire curve is 100%. Okay. So what they're asking us to do in this example, let me do another example here. So let me go back and just clear this out. All right. So let me use our example here. The mean is 81.2. So I'm going to put that here in the center. And they're asking me to find let's do the first quartile. Well, the word quartile means 25%. So what that's asking me is what number here would cut off an area of 0.25. That's what the first quartile is. It turns out there's a formula for this. And let me see if I can find the page number. If you go to page 515 in the textbook,
okay,
there's a section called quartiles. And under that, here's what it says. If you want to know the first quartile, we label that as Q sub 1. It's equal to the mean minus 0.675 times the standard deviation. The third quartile, go ahead.
Yeah. I'm bringing my reader up. I'm sorry, you said 515 or 5?
Page 515, yes.
Okay. And got it.
And then there's a section there called quartiles. I think it's paragraph number 4, it's labeled. You notice there it says in a normal distribution, Q3 is equal to the mean plus 0.675 times the standard deviation.
Yes.
And also same kind of information for Q1. So these are two important formulas to write down somewhere because we're going to be using these in many problems. And so these two formulas are going to give us what we need to calculate this first quartile and third quartile. Let me plug in. Let's do the first quartile here together.
Okay.
So the formula says take the mean, which in our example is 81.2, and subtract 0.675 times the standard deviation, which is 12.468. And I can just work this out on my calculator.
Was that 72.83?
You got it. And this problem says round to one decimal place.
Okay.
So 72.8.
72.8.
Sounds good. Yep, exactly right. And then the third quartile, the formula is the mean plus 0.675 times the standard deviation. So in our example, this is going to be 81.2, that's the mean, plus 0.675 times 12.8.
So 89.6.
You got it. That's the right answer. Good.
Okay. Will it ever ask for like Q2 or Q4?
There's only three quartiles. There's Q1.
Sorry.
Yep.
Yeah.
There's Q1, there's Q2, there's Q3. Q2 is actually the same as the median. So Q sub 2 is the same as the median of the data. The median, you might remember, is like the middle value in a set of numbers. So if you put a set of numbers in order from smallest to largest, the median is that one number that's right in the center of the ordered numbers.
Okay.
All right, let's do a few more. So number 4 is exactly the same.
All right, so number 4, let me get that one here. So I've got mu is 2354. Sigma is 468. We're looking for Q3 and Q1. So Q3, I'll just do that here. Q3 is going to equal 2354 plus 0.675 times 468. I'm just going to write the equation for the next one down as well.
Yeah.
Or minus 0.0675. Okay. All right. Let's see. So Q3 is going to equal I got 2669.9.
Yep, and I think it says round to the nearest whole number.
Oh, so 20 or 2670.
You got it. That's right. Good.
Okay, and then the next one. And the next one's going to be 2038. So Q1 is 2038.
Yep, that's right.
Q3 2670. All right, perfect. Thank you.
All right, good.
So those, I'm going to star those so I have those formulas. Okay.
All right.
Oh, I do have a question while looking through these, if you don't mind. So in the video when it talks about the z-scores,
Yes.
and it talks about just go online, find a chart, or look in the back of the book. When I checked the book for the z-score chart, I couldn't find the full one. I found them online, and like the positive and negative z-scores.
Right.
When I compared them against the chart that she was using in the video, I noticed there were a couple of values in the, like,
Yeah.
I don't even think the thousands, like the
Right.
10,000th
Yeah.
place was like one digit off. Is
Well,
it,
yeah.
is that going to be enough to affect anything?
Well, there's um maybe we should talk about z-scores first, and then we could
Okay.
talk about finding these areas under the curve. So it
Okay.
turns out when you're finding these areas under the curve that I was mentioning, there is an approximation you can use, and it's called the empirical rule. Let me show you what I mean by this. If you could see my screen,
Okay.
this is a chart. I think I posted this in announcements. This is a chart that is essentially shown on page um, on page 516, but not exactly in this format.
Yeah, I've got
See
it
what
on
I'm,
your from your lecture.
yeah. And this curve is sometimes called the empirical rule,
Okay.
or sometimes it's called let me see what they call it, the 68 99.5, I'm sorry, 95 99.7 rule.
Mm-hmm.
Bob, if you go to the bottom of page 515,
Yes, figure
right below that
17
paragraph on
essentially.
quartiles, do you see where it mentions 68 95 99.7?
Yes, sir.
That's this diagram that I have up on the screen. Now, if you use this diagram to find areas under the curve, which is what these percentages are. Can you see these percentages here, like 13.5% or 2.35% on this diagram?
Mm-hmm.
Those percentages are referring to the shaded areas under the curve. So when you're finding these areas, you can either use this diagram or you can use that lookup table in the back of the book. Now, this diagram is going to give you slightly different answers versus using that lookup table in the back of the book. Because you could see here, they rounded these percentages. And the answers from that table in the back of the book will be slightly different, out to like the third decimal place or something like that.
Mm-hmm.
So what it means is we have to read a problem carefully. Let me scroll down and see if I can find an example. When you see the word approximately, you see in this example I have here, it says approximately what percent of the data? When you see the word approximately, that's really guiding you to use that diagram, that empirical rule.
Okay. Larry, I think you muted for a second. Larry, can you hear me? I'm having trouble with microphone.
I'm sorry, Bob. I dropped my tablet before and it knocked out my microphone. Let
No
me back
worries.
up. What I was saying is that diagram I was showing you looks like this.
Mm-hmm.
It's called the empirical rule. And this gives you approximate areas under the curve, under the normal curve. So
Okay.
the answers you get using this diagram are going to be slightly different than the answers you get from that table in the back of the book. Because you'll notice these percentages here are kind of rounded percentages.
Mm-hmm.
So how will you know whether to use this diagram versus the table in the back of the book? Well, if I go down to some questions here, you're going to notice it says, approximately normal. You see the word approximate?
Mm-hmm.
Let me go to this one. It says approximately what percent? When you see the word approximately mentioned like this is guiding you to use that diagram, not the table in the back of the book.
Okay.
So let's come back and do some of these examples in a minute. I'll show you what I mean about using that diagram. Before we do that, why don't we do a few z-score examples?
Sure.
Just to make sure that's clear. So here is question 7. All right, so what is a z-score anyway? Well, a z-score is a way for you to take a measurement and convert it to a scale. So I'm going to use my biology exam score. I'm going to convert a biology exam score to a z-score.
Okay.
A z-score is where you take a measurement. Let's say my score, my exam score on the biology exam was 45. And you say, oh, that's terrible. You did very, very poorly on this biology exam. You only had a 45. And I would say, no, wait a second. You've got to take into account how the rest of the class did. Maybe 45 is a good score. You know, if the average score in the class was a 30, then a 45 is a good score. So what the z-score lets you do is figure out how you did relative to everyone else in the class. And what it does, the z-score is translating to a scale of -3 to +3, roughly.
Okay.
So what I'm going to do is take my biology score and translate it to the scale from -3 to +3. This is what a z-score turns out to be. If your z-score turns out to be a 0, that means you scored exactly at the average of the class. So a z-score of 0 means you're an average person. A z-score of 3 means you did 3 standard deviations above the mean. This means you are a superstar. You're like at the top of the class. If your z-score is -3, you did very poorly. So here's the formula we're going to use. This exam score of 45, we usually call the X value. So let me write down the formula for a z-score, and let me find it in the textbook. Hold on a second. Yeah, if you go to page 518.
Is that x minus mu over sigma?
You got it. Exactly right.
Okay.
Yep. So here's the way you calculate a z-score. I'll write it up. Let me write it down in words to make it easier. You take the measurement you have, subtract the mean, and divide by the standard deviation. In symbols, this would be x. X is like the measurement or the score. Mu is the mean, and sigma is the standard deviation. So this is the formula you see on page 518. So let's do it for my biology exam score of 45. Let's say the mean score was 35, and let's say the standard deviation was 5, just to make up an example. So in my example, mu is 35 and sigma is 5. All right, I'm going to plug into this formula then. It says Z is my measurement or my score. That's 45 in my example, because that's what I scored on the exam. Minus the mean, which is 35, divided by the standard deviation, which is 5. So this turns out to be 10 over 5, which is 2. So in my example, the z-score is 2. But what does that mean? Well, a z-score is really telling you how you did relative to everyone else in the class. So what it's measuring is how many standard deviations were you above or below the mean. If my z-score is 2, that's telling me I scored 2 standard deviations above the mean. I did very well on this exam. I'm in like the top 90% of students, for example. I'll show you this on the normal curve in a second.
Okay.
So does it make sense how you can use this formula to find the z-score?
That does, yes.
Let's do it. Let's do this example 7. Let's do one of these.
Sure.
So let's go here to number 7. Let's do part A. They're giving me the x value is 98. I know the mean is 110 and the standard deviation is 12.
So it's going to be 98 minus 110 over 12.
You got it. Good. Now, one thing to be careful about, though, if you do this on a calculator, Bob, you have to put the top of this fraction in its own set of parentheses. So on a calculator, you've got to enter this as parentheses, 98 minus 110, close parentheses, divided by 2. If you forget those parentheses on your calculator, you're going to end up getting the wrong answer.
Yeah, I've been between my issues with basic algebra and using my calculator. I usually just break it down into, like, I'll just do a 98 minus 110 separately, and then
that works.
Just because I've noticed if there's a chance for me to do the improper order of operations, I will do it.
Yeah, that works too. Yeah, the rule for a fraction is you have to work out the top of the fraction separately and the bottom of the fraction separately, and then do that division last.
Mm-hmm.
So all of these examples here in chapter 7 are going to be very similar. I mean, in problem 7.
Okay. So in that one, I got -1. So it ended up being -12 divided by 12. It's just -1.
Good. All right. Now, let me see here. Let's go to let's see what else we got on the list here. So that was number 7. Number 8 is exactly the same.
Mm-hmm.
Let's talk about number 9, because number 9 is a little different.
Oh,
number
okay.
9 is giving you the z-score and asking you to figure out the original x value.
So part A, let's just do that. So that's going to be 2 equals x minus 83.2 divided by 4.6.
Good.
Okay.
Now,
let's see here. Yep.
I need to somehow get this x by itself. And one thing I'd like to do here is get rid of this fraction. You notice on the right-hand side of this equation, there's a fraction.
Mm-hmm.
What if I was to multiply both sides by 4.6? Now, before I do this, Bob, there's another equation that you can use if you don't want to do this algebra stuff.
Okay.
And let me point it out to you. If you go to the top of page 519, and towards the end of the second paragraph, it's hard to see it, but the formula looks like this. X equals mu plus sigma times z.
Let me write that over here too.
And what this formula is doing is it's just taking the original z-score formula. Remember, it was z equals x minus mu over sigma.
Mm-hmm.
And it's just doing a little bit of algebra rearranging.
Okay,
So it's like
perfect.
someone has done the algebra work for you there.
So in this case, we could just do, let me see. So x equals, grab that again, mu plus, all right. So this would just be x equals 83.2 plus 4.6 minus z.
Times z. That's a time.
Oh, excuse me, times z.
Yeah. And in this example, part A, z is given to us as 2. So replace z with the number 2.
So 4.6 times 2, which would be what, 9.2. Okay. 9.2 plus 83.2. So we're looking at 92.4.
Exactly. You got it.
Okay. Yeah, I like that one better because I will, like when I look at that, I don't know why, but I want to like either add X or like divide by X. And I know that's not the right order, but
Yeah.
so I'm glad that it's already done for me.
Yeah, it's already done. Good. All right. Let's see what else we have. Let's do one of these examples.
So when do you use the z-score chart?
Yeah, let's go to an example of that.
Okay.
Let's do this example, Bob, here. It's question 13.
Okay.
All right.
Distribution. Okay.
And I'm going to bring up this chart. Let's see if we can use this to help us. All right. Let me just double check something, Bob, here for a second. Just want to double check. All right. Let's come back to 13. 13, I think, is a little trickier. Let's do another one first.
Okay.
Let's do number 14.
Okay.
All right. So it says here a normal distribution has a mean 500, standard deviation 35. What percent of the data is between 465 and 605?
All right. So when I hear this, so I'm assuming we're going to be doing two problems and then compare, like subtracting one from the other, right? Like we'll solve for something using 465. We'll solve using 605, and then we'll go the higher minus the lower.
That would be if you were using the chart in the back of the book. Yeah. But
okay,
let me use this chart because I'm noticing the wording says approximately what percent of data. And here's the way I'm going to use this chart. If you notice on this horizontal axis, can you see these numbers here on the horizontal axis?
Yes.
What I'm going to do now is I'm going to put numeric values on this horizontal axis. All right, let me start. I'm going to go right to the middle where it has mu. Mu is the mean. In this case, it's 500. So I'm going to write a 500 right here. Does that make sense? The mean is 500. Let me go over to the right one notch here. It says calculate the mean plus 1 times the standard deviation. In our case, the standard deviation is 35. So I'm going to put here 500 plus 35. Well, that's going to be 535.
Okay.
Does that make sense?
It does.
Let me go over one more notch here. It says the mean plus 2 standard deviations. Well, the mean plus 2 standard deviations would be 500 plus 2 times 35. Well, that's 500 plus 70. That's 570. So I'm going to mark 570 right here. I'm going to do one more here. Notice it says mean plus 3 standard deviations. Well, for the mean plus 3 standard deviations, that's going to be 500 plus 3 times 35. 3 times 35 is 105. 500 plus 105 is 605. So I'm going to mark 605 right here. Does that make sense how I just came up with those 3 numbers? I'm kind of just following the labels that are on this horizontal axis, right?
And just the same for the negative side as well.
Let's go to the negative side. Yeah, let's come here. It says mu minus 1 sigma, 1 times the standard deviation. Well, mu minus 1 times the standard deviation, that's going to be 500 minus 1 times 35.
465.
465. Now I'm going to stop here. I could do the other,
right,
but I don't need it because I'm noticing the question. The question says, what percent of data falls between 465 and 605? So here's what I'm going to do, Bob. I'm going to mark in purple vertical lines corresponding to the interval they're asking me about.
Okay.
So they're asking me to go from 465, so that's this purple line, if you can see it, over to 605, which is this purple line. So they're asking me to find this area in this purple interval. Well, that means I'm going to add up the percentages under the curve in this interval. So the area I want then is going to be this 34% plus another 34% plus this 13.5% plus this 2.35%.
So
I'm going to add these up.
83.85.
34 plus 34 plus 13.5 plus 2.3.
So I got 83.85.
83.85. That's the answer to this question.
Oh, perfect. I like that one much better.
So what we did for these kinds of questions is you got to take this diagram, mark off the horizontal axis. It'll give you the mean and the standard deviation. So you should be able to mark off, all of these tick marks on the horizontal axis. And then use vertical lines like I just did to delineate the interval they're asking you about. I used purple lines here to go from 465 to 605. And then you just add up the percentages that fall within whatever interval you marked.
Is there an easy way, or at this point, should I go back to the other way to solve? If something comes up in a value of, instead of 605, let's say it said between 465 and 595. And I know the answer 595 is going to fall somewhere halfway between.
That's right. Good point. If you were asked about 595, 595 doesn't show up on this diagram. So I really could not use this diagram.
Okay.
For that, I would go to that table in the back of the book.
Okay.
Now, what if you had done this problem using the table in the back of the book? Well, if you had done that, and you can do it, you would have gotten a slightly different answer than 83.85%. It might have been something like 861 or something like that. But the word approximately is what triggered me to use this diagram. Because this diagram are the approximate areas under this number. Maybe we should do another example like this.
Yeah, please.
Maybe I'll let you try one of these.
Let's see.
There we go. You could pick one too if you see one that looks good. Let me go to number 15. Because number 15 is actually similar to what we just did. Now, let me go back to this diagram. If you notice on the horizontal axis here, they're marking the mean plus one standard deviation, and so on. Think of this as the actual X values here. These are like salaries or blood pressures or whatever you're measuring. But I can convert these to Z-scores. So I can use the same diagram, and let me mark the Z-scores in purple so you can see it. So I'm going to change this over to be Z-scores. Well, the mean is a Z-score of 0.
Sure.
Mu plus 1 sigma, that really corresponds to a Z-score of 1. This corresponds to a Z-score of 2 and a Z-score of 3. If I go to the left, the Z-scores are going to be -1, -2, -3. So I can use the same diagram, but use Z-scores instead. So let me go to question 15. In question 15, part A says, find the area for Z less than or equal to 2. I know it says what percent of the data, but when they say what percent of the data, that's really analogous to finding the area under the curve.
Okay.
All
So
right, so let
would
me
that
draw a
would
purple. Yeah, go ahead.
I
Let me draw a
was going to say,
purple line
would
here
that
at
just
this.
be like 95%?
Well, I would have to add up all of these areas that I'm going to circle here in purple. Now, here's a little shortcut.
Oh, I see. Okay.
I know I could add up these areas that I just circled in purple, and that would give me the answer. It turns out if you add these up, the sum of these areas turns out to be 97.5. But here's a little trick to save some time. Notice up here at the very top, it says the total area under this curve is 100%.
Mm-hmm.
So to make things a little easier, what if I just added up these areas over here on the right that I really don't want to include? These areas here that I'm circling in red add up to 2.5%. So the purple area I want, I can calculate as 100 minus 2.5 as a shortcut, which of course still works out to be 97.
Okay, I got
So
you
you
now.
can either add up the percentages I circled in purple, that would be good, or you could take 100% minus the areas I circled in red, get you the exact same answer. So it's up to you, whatever you think is easier.
And then on the next part, when it says it's less than or equal to 1, but and less, let's see, less than and equal to 1 and less than and equal to 2.
What that's asking you is what's the area between, let me write this down here. This part is asking me what's the area between z equals 1 and z equal 2.
Okay. So that
Well,
would just be the 13.5%.
you got it. Good.
Gotcha. Okay. Yeah, those I'm a little like I said, when you explain it, it makes sense. Now I think that I have the chart and I drew down the values. I think that'll help more because I was kind of following when they were showing like, yeah, it's shaded this percent, this, but I couldn't really grasp
Yeah.
how we were getting
And
there.
the diagrams on the top of page 516, I think are harder to work with. I don't like the way they present this at the top of page 516. I think it would be better to present the diagram that you were just working with, Bob, because that's, I think, easier to see all the percentages. Do you want to try an example here, Bob, like number 16, for example, here?
Sure.
And I'm noticing number 16 says approximately normal distribution.
2,500 students take college exam scores. Approximate normal distribution of 52.
And Bob, while you work on this for a minute or two, I'm going to take a very quick break. I'll be back in 1 minute.
Okay.
And of course, my suggestion here is take this diagram, mark off the horizontal axis, and just to help you get started, I'm going to put a 52 here in the middle, right? Because the mean was 52. And the standard deviation was, I got this down. The standard deviation is 11.
11.
So what that means is I put 52 here in the middle. Going over to the right, it says mean plus 1 standard deviation. That's going to be 52 plus 11, 63. And I'm going to let you fill in.
Okay.
And then once you have the horizontal axis marked off or labeled, you should be able to answer these parts A, B, C, D.
So
I'm going to take a 1 minute break. I'll be right back.
sure.
Should we take a look at Bob? Are you still working?
I'm working on the last part.
Okay.
So I've got that. Okay. So when I see the average score, I put mu, which is 52 points.
Good. Exactly.
For B, estimate the percentage. I don't know why I should have looked at it, but instead I got caught in the numbers and I did the math and then realized I could have just everything right of, which is 50%. So if
Good.
if 52 is the medium, so of course everything is going to be right of that's going to be 50.
That's right. And even if you didn't remember that, if you add up
Right.
those percentages to the right, they will add up to 50. Good.
Mhm. 41 to 63. So 41 is one standard deviation to the left or below, up to one standard deviation above. So I just added those percentages up and got 68%.
Good. Those are the two blue areas, right? In the center there. Add up 68.
Yes.
Good.
And then for the other one, 63 or more, which we said was one standard deviation above, up to the end. So just 34 plus 13.5 plus 2.35 plus 0.15. Which was, or wait, no, I'm sorry. Wait, 63% or more.
Let me mark, Bob, let me mark in purple.
Yep.
This vertical line here at 63.
Yep. I'm sorry. That's actually what I got. I got 16%, but then when I went back and just explained it, sorry, not past the first standard deviation, it's just 16.5 plus 235 plus 0.15.
You got it. Good. Answer 16% overall. You got it. Nice.
Yeah, that chart definitely helps.
Yes.
Let's
see what else we have.
17 is pretty much the same.
Yep.
18.
How about 18? 18 is a little different.
Yeah. Okay.
So here's the only thing you'll do for 18 that's a little different. Let's do quickly part A.
Okay.
So I'm going to get my diagram up, and I'm going to mark in the center here 125 because that's the mean. And the standard deviation is 13. So I'm going to be adding 13 going to the right. So that's 138. Add 13 again. I think that's 151. And add 13 again. That's 164. All right, let me go to the left here. 125 minus 13 is 112. And 99 here.
Okay.
All right, so I have my horizontal axis marked off, right? Does that make sense?
Mm-hmm.
Let me go to part A. It says, what is the number of patients? Notice it's not asking me for a percentage.
Mm-hmm.
It says, what's the actual number of percentages that have blood pressures between 99 and 151?
So for this one,
yeah.
I'm sorry, for this one, am I going to just, so we'll add the percentages like we did before,
Yep.
and then I'm just going to multiply 2,000 by that percentage?
You got it. Exactly right.
Okay,
that's the
perfect.
only wrinkle on this one. You got it.
Okay, so let's see.
By the way, Bob, I'll just mention, you know, in my diagram that I have up on the screen, you notice my purple lines, instead of me adding up those percentages myself, you notice up here, it's already giving me that between those two vertical lines, that happens to be 95%. So that saves me a little bit of time from having to do the addition myself because they already labeled it as a 95% area between my two purple lines.
Gotcha. Yeah, that's true. I keep forgetting about that part. I keep just wanting to jump into it instead of taking
And
a
that's okay.
second to actually look at
No,
it.
that's okay too. You can add them yourself. You get the same answer. Let's see here, Bob.
So
I gotta jump off in just a second. Let's see if there's anything
sure.
that's different. 19 is going to be very similar. Let me mention 20 because I think this will help. When you see the word percentile, so let me let you look at 20 for a second. This is asking you to find percentiles. Now, a percentile really just means find the area to the left
Okay.
of whatever measurement they're giving you. Let me do part A with you quickly here.
Sure.
So let's do part A. All right, so I'm going to put 125 in the middle.
Mm-hmm.
And I'm going to subtract 13 going to the left here. So this is going to be 112. And I'm going to stop there because that's all I need. So I'm doing part A. It says find the percentile that goes along with the measurement of 112. I'm going to put a purple line here at 112. Can you see this purple line?
Yes.
When they say percentile, they're asking you to find this area to the left. So all I have to do is add up these three numbers because those are the areas to the left of this measurement of 112.
So was it 16? Just off the top of my head. Okay.
That's right. You got it. And so the answer to that problem is 16th percentile.
Okay.
So when you see the word percentile, it's really asking you add up all the areas to the left of whatever measurement they give you.
Write that down here. Okay.
All right, Bob, I apologize. I got to jump off. But please try these examples. Email me with questions. If you get stuck on any of these examples, email me and I'll be glad to help out.
I have one quick question, Larry, if you don't mind. I'm sorry. So what is the keyword like when I know to look into the Z-score table? Or using these other methods, I won't need the Z-score table.
If you notice that they give you a measurement that doesn't fall on this axis that you marked off, then you can't use this diagram.
Mm-hmm.
Let's say they asked you to find the percentile for 110. Well, 110 is not marked on this diagram. So you could not use this diagram. Then you would have to use that table in the back of the book. It would also not use the word approximate. Notice how in the wording of this problem they use the word approximately.
Mm-hmm.
I think most questions say approximate. Most questions are going to use this diagram. But if you didn't have a number that appeared on your horizontal axis, you would have no choice but to use that lookup table.
Okay. Or if it said something like 0.8 standard deviation from,
right,
and then I would go to the 0.8 and then find that way.
You got it.
Or if it says a Z-score of this, find the percent or find the standard deviation.
Yep.
And then you work backwards. Okay, awesome. Thank you. That's much easier.
Okay.
Larry, I appreciate it.
Yep. Hang in there. We're almost to the finish line. And again, email me with some questions as you come across.
Will do. Thank you again.
Thanks, Bob.
Yep.
Bye.
Bye.